Okay, Rifat, good. Okay, I hope Fahd, my voice is audible to you also. Now we will continue our last topic. We are doing the properties of matrix addition. Okay. Okay, so sorry, we were doing the matrix addition and I have given you some homework. So this question, Rifat and Fahd, you have completed this question? Rifat and Fahad, this question is completed. Sorry, Fahad, I can't hear you. Fahad and Rifat, this is done. Oh, okay, Rifat. Okay, Fahad, I will solve this. Okay, check here. So in this case, what you need to do, Fahad, we have this question A plus matrices 2, 3, minus 1, 4, and this is equal to next matrix, that is 3, minus 6, minus 3, and 8. Okay. So shift this to the right side. You will get A is equal to, so you will get here 3, minus 6, minus 3, and 8, and minus, then you have this 2, 3, minus 1, and 4. Okay, so A is equal to, now subtract these two. So 3 minus 2, this will become 1. Then minus 6 minus 3 will become minus 9. Minus 3 plus 1 will become minus 2. And 8 minus 4 will become 4. This clear? First? First, this is clear? Okay, very good. Okay, so first, please note down this. Then we will continue our topic. First, shall we move to next question? Very good. Next is properties of matrix addition. Okay. So first is commutative property. These are the basic properties you have done in the previous classes. Okay. So what's the commutative law? If you are adding A plus B and you are adding B plus A, then this is the same thing. Okay. A plus B is equal to B plus A in case of matrix addition. Okay. So no need to discuss further about this. Associative law. If you will add A plus B, then finally you will add that in C is equal to, if you will add A, then plus B plus. Okay. Third one, existence of additive identity. So suppose if you have a matrix A, then can you tell me what matrix we will add in this matrix so that you will get the same matrix? Fahad and Rifat, what matrix can we add so that we can get the same matrix? Null matrix. Okay. Very good, Rifat. This is correct. Okay. So the null matrix is the identity element for the matrix addition. Now, fourth one, existence of additive inverse. So suppose we have a matrix, then what matrix you will add in that so that you will get a null matrix? Minus A. Very good, Rifat. Minus A. Okay, so please note down this and raise your hands once it is done. Then we will move to next topic. Okay, Rifat, very good. Fahad, this is done. Shall we move to next? Okay, great. We have some more questions on addition of matrices. Okay, we have done in the previous batch, but right now we don't have so much time. Okay, this is a very good question. Yeah, please try to solve this question right now. Okay, so you have two equation, x plus y is equal to this, x minus y is equal to this. You need to solve this. So how can we do this? We can write like this, x plus y is equal to 7025. We have x minus y. This is equal to 3003. Okay, 03. Now add 1 into. Okay, add these two. So what will happen? This y will cancel out. X plus x will become 2x, and this will become 7025 plus 3003. 3003. So this will become 2x is equal to, now add these two, so you will get here tan 0, 2, and this is 8. Now this 2 can be shifted to right side, so you will get x is equal to 1 by 2, okay, tan 0, 2, 8, and this is x is equal to, divide this with 2, so you will get 10 by 2, 0 by 2, 2 by 2, 8 by 2. Okay, so this we will get x is equal to, this is 5, 0, 1, and 4. Okay, now you get the value of x. Now please put this value of x in any of the equation. You can get the value of y. Okay, so please complete this. Share the answer with me. Share the value of y. Okay, further Rifat, please share your answer if you have completed this. For we get the value of x, so please put this value of x in any of the equation. We have two equation, 1 and 2. So please put the value here. Okay, Rifat, you get the answer. So answer is 2, 0, and 1 and 1. Very good, Rifat. This is correct. First, please put this value of x in any of the equation and find out the answer. You need to put the value. Okay, for please check here. In place of x, put this matrix 5, 0, 1, 4 plus y is equal to 7025. 7025. Okay, first. Now, how can you find the value of y? You need to shift this matrix to the right side. So this will become negative. So you will get this. Y is equal to 7025 minus 5014. Okay, Fahd. Now please try this one.
So the answer is 2011.
2011. Very good, Fahd. This is correct. Okay, this question is also homework. Okay, we don't have the time right now. So please note down this. These are the answers. I know you can solve these questions. Okay, please note down this. And we can discuss this in the next class if you will have a doubt, but I know you can complete these. Okay, Fahad and Rifat, this is done. Shall we start next? Okay, Rifat, this is done. Okay, good. This question is from NCRT exemplars. This is also homework. This is a very good question. Please try to solve this at home. Okay. Please note down this and confirm me. Uh, Further refer, please confirm me if it is done. Okay, Rifat, this done. Okay, good. Okay, so this question came in CBSE 2000, but oh, there's a simple question. You can do this in the homework. Please note down this. Okay, please raise your hand once it is done. Then we will start the next one. Okay, Rifat, good. First, this done. Shall we move to next? Okay, good. Okay, this question came in CBSE 2019. So please note down this is also homework. Okay. Raise your hands once it is done.
So sir, instead of A, what we have to substitute? A value is not given, right?
Yes, so you have to substitute B and C.
Okay.
Okay, then the only variable we can say is A. So you can find the value of A from here. Okay. I'm sorry, actually, we don't have so much time. If we will do each and every question in the class, then it is not possible for us to complete these chapters on time. Okay. But in case you will face doubt in any of these questions, then we can discuss this in the class. Please raise your hands once it is done. Okay, good for it. Okay, Rifat, very good. This you can do on your own, no need for this. Okay, we will start now the next topic. Next is multiplication of matrices. Okay, so before starting the multiplication of matrices, we will check that in at what condition we can multiply two matrices. Okay, please check here. Suppose we have a matrix A and its order is n by p. Suppose we have a matrix B, it have a order p by m, suppose. We can multiply two matrices only if the number of order of the first matrix will be equal to number of rows of the second one. Number of columns of first matrix will be equal to number of rows of the second matrix. Only in that case you can multiply two matrices. Please remember this. You can multiply two matrices only when the number of column of the first matrix will be equal to number of row of the second matrix. Okay, so here we are checking that in what condition we can multiply two matrices. What is the condition for addition? When can we add two matrices? When they have the same order. What is the condition for multiplication? When the number of column of the first matrix will be equal to number of row of the second matrix. Okay, so this is the condition. Now suppose you're multiplying two matrices and you're getting a C, a resultant matrix C. What will be the order of C? The remaining which numbers which are present here. But please don't disturb the sequence. First you have an, write then you have an, write then. Okay, so Fahad and Rifat, this is clear. In what condition can we multiply two matrices? When the number of column of the first matrix will be equal to a number of row of the second matrix. Okay, okay, now the same thing is written in this complete language. So please note down this. Let A and B be two matrices. Then the product AB is defined. That means when we can multiply this, if the number of columns in matrix A is equal to number of row in matrix B. Okay, this means this one. These two are same, then we can multiply. And what's the order of the resultant? That is m by b. Okay, next is if A and B are two matrices such that AB exist, then BA may or may not exist. What is meaning of this? Please, first of all, check here. Suppose we have a matrix A having the order 2 by 3. We have a matrix B, we have an order 3 by 4. So Rifat, please tell me, can we multiply these two matrices A and B? Okay, Rifat, so suppose we are getting a matrix C, what will be the resultant order of matrix C?
2 by 4.
2 by 4, very good. Now please try to multiply B with A. B have the order 3 by 4, A have the order 2 by 3. Please try to multiply this. Is it possible to multiply these two matrices?
No.
No. Okay, the same thing is written here. If A and B are two matrices such that AB exist, that means you can multiply AB, then BA may or may not exist. Okay, BA may or may not exist. So I hope this point is clear to you. Next point is if multiplication of two matrices is null matrix. If multiplication of two matrices is a null matrix, then it is not necessary that either A or B are null matrix. What's the meaning of this? Suppose we have two numbers, real numbers. We are multiplying these two numbers and we are getting zeros. So suppose if the first number is 2, you can say that the next number is 0. Okay, you understood this. If we are multiplying two real numbers and you are getting a 0, then that means if one number is 2, then the other will be 0. So for the real number, it is necessary that one of the numbers should be a 0. Then only you will get a 0 in the end. But the same thing is not true for a matrix. If we have two matrices, we are multiplying these two and we are getting a null matrix. Then it is not necessary that either this is a null matrix, this is a null matrix. We will see some cases where A and B are not the null matrix, but still after multiplication, we are getting a null matrix. Okay. So we will check some example in this one. There's some questions we will try to do. Okay. Next is, okay. So please note down all these 3 points, then we will solve some questions. Okay, please raise your hand once it is null matrix means there is no element. Yes, sir. Null matrix means all the elements are 0. Okay. Actually, first there is the topic types of matrices, okay, which we have done last week. Let me complete this chapter. I will again explain to you that what is it, what are types of matrices. Okay, okay, Fahad, very good. So, Rifat, please raise your hands. Once you will complete this, then we will try some questions. Okay, Rifat, very good. So we are moving the next question. Okay, this is a very, very good question. Assume X, Y, Z, and P. These are four matrices. They have these order 1, 2, 3, and 4. They have these order and this one. Okay, five matrices. Choose the correct answer in Q1 and 2. So first is the restriction on N, K, and P so that Py plus Wy will be defined. So what does this mean? You are multiplying Py, you are multiplying Wy, and you are adding these two. Okay, so what is the restriction on this? So if you will check, what is the order of P? P is P by Q. What is the order of Y? Y is 2 by P. Okay, plus what is W? N by 3.
So y is 3 by q, no?
Y, sorry, Y is 3 by Q. Y is 3 by K. Here also we have a 3 by K. So we are the restriction on N, K, and P so that Py plus Wy will be defined are, these are the options. Okay, so please tell me which is the correct option here. Okay, so take your time, please check which is the correct option. Further, this means any random value. Okay, so P is arbitrary means P can have any value, any random value. Okay. Okay, so I hope both of you has tried to solve this question. Please check here. These two should be same. We can multiply this when these two should be same. So from this, we will get k is equal to 3. Okay. Suppose we are multiplying this and we are getting a result in matrix C. What is the order of C? P by K. We are multiplying this. Suppose we are getting a result in matrix D. What is the order of this? N by K. And we are adding these two. So what is the condition? When can we add two matrices? When they have the same order. So that means P by K is equal to N by K. So So that means P is equal to N. So we get all these values here. K is equal to 3. We get K is equal to 3 and P is equal to N. So we will check the first option. This is correct. Check the second. K can have any value and P is 2. No, this is not correct. P can have any value. K is equal to 3. This is correct, but P can't be arbitrary value. It should be easy. It should be equal to N. P is 3. Okay. K is 2. Sorry. K is 2. No, not correct. P is equal to 3. We don't have this. Okay. So the correct option is A. This clear? Further refer. Okay, Fahd, good. Rifat, this clear? Very good. So please mark the first option. Okay. So shall we proceed? I hope you have done this. Okay. Now we are proceeding to the next one. Mark the correct answer. Correct answer is A. Just leave this you can do later on. Okay. Now next question is, you have two matrices. You need to find A, B and B. A, B. Okay. What is the order of A? Who can tell me? Fahd, what is the order of A?
2 by 2.
Very good. What's the order of B?
3 by 3.
Not 3 by 3. Count the number of rows.
Oh, 2 by 3, sorry.
2 by 3. 2 by 3. So first, can we multiply these two matrices?
Yeah, we can multiply. Because
We can.
first, yeah.
Very good. These two are same. So AB is equal to what? We have this matrix 6, 9 and 2, 3. Okay. We have next matrix 2, 6, 0, 7, 9, 8. Please check carefully the steps for multiplication of matrices. How can you multiply two matrices? Take the first row, this one, and multiply the first row with the first column. So 6 will get multiplied with 2, so 6 into 2, plus 9 will get multiplied with 7, so 9 into 7. Okay, 6 into 2 plus 9 into 7. First row, second column. So 6 into 6 plus 9 into 9. First row, third column. 6 into 0 plus 9 into 8. Next one, first row, first column. So 2 into 2 plus 3 into 7. Next, first row, second column. So 2 into 6 plus 3 into 9. This second row, sorry, first column. So 2 into 0 plus 3 into 8. Okay. So what you need to do, first of all, take the first row, multiply the first row with the first column, second column, and third column. Take the second row, multiply the second row with the first column, second column, and the third column. This is clear to both of you. Further refer. Further and refer. This is clear. Because if you understood the first question, then you can solve the remaining one. Okay, very good. Now what we do, we will multiply this. We will get a 12 plus 63, 36 plus 81, 0 plus 72, 4 plus 21, 12 plus 27, 0 plus 24. This is equal to what? 75. Okay. This is 87 and 3, 117. This is 72. This is 25. This is 39. And this is 24. This is the final answer. Okay. Please note down the steps. Then we will check the remaining questions. Please note down this. And raise your hand once it is done. Abdul, we will wait for other friends. Okay, then we will continue the functions. In
Okay,
the
okay.
in the meantime, Abdul, please revise the functions. Okay. Fahad and Rifat, please confirm if it is done. Then we will try some other question. And further, Rifat, please check your portal after the class. Okay. So I already asked the team to share the assignments with your matrices. So apart from these questions, please try to do the assignments if you will get the time. Okay. Okay, Fahad. Okay, Rifat. So we will start the next question. Okay. So here you need to find AB and BA. So please just find AB. Okay. We don't have so much time. So please find AB. Note down this question. This is a homework. Please find AB and tell me the answer. Uh, Further, Rifat, once it is done, then please share your answer. Very good, Rifat. This is correct. Further, please check the answer. This one. Okay, fine. Very good. Okay, so in next class we will continue the same topic, matrices. Okay, so the rest of the questions we will check in the next class. Okay, please try to do the assignments of matrices. Okay, so relation and functions we were doing. I have given some homework. So everyone has done this. Fahad, Rifat completed the homework of relation and function. If you have not completed the homework, please do this week. Okay. Next, we will continue this question. Okay. Please check here. So what's the question? Show that this function defined by fx is equal to, and today we will start the new chapter also, differentiation. Okay. Rifat, I guess in your exam, the differentiation is coming.
Yes.
Okay. Okay. Wait. So show that this function. Show that this function defined as fx is equal to 1 by x is 1, 1 and on to both, where R naught is a set of all non-zero real numbers. Okay. So first we will check 1, 1. Okay. I hope you can do this question on your own. So what we need to do, let x1 comma x2 belongs to the first set. What is the first set? R naught. Domain. Let x1 comma x2 belongs to R naught such that fx1 is equal to fx2. Okay. Now what is mean by fx1? Fx1 is 1 by x1 is equal to 1 by x2. Please check here. Here the set which is given is non-zero real number. That is 0 is not included here. Okay, please check here in the denominator we should never have a 0. Okay, so that means this is correct because the set we don't have any 0. That's why this 1 by x1 is equal to 1 by x2 is correct. Now take the reciprocal both sides, you get x1 is equal to x2. Hence the given function. Hence the given function. Hence the given function is 1 now. Is 1. Okay. So please note down this, confirm me, then we will check for onto. Ananya, this is your first class. Ananya, this is your first class. Ananya, you can unmute yourself, okay, or you can reply me on the chat box. Ananya, if my voice is audible, then please reply me on the chat box. Okay, so further Rifat, this is done. Shall we start next? Okay, Abdur, you have joined again. So please note down the first answer, Abdur. Yesterday we were doing this question, and please do it fast because we need to start a new chapter today. Okay, okay, Ananya. Okay, Abdur, please note down this and confirm me, then we will start the next part. So Ananya, this is your first class.
So can you explain it?
Okay, Abdur. Abdur, so we have this function from R to R defined by fx is equal to 1 by x. Okay, we need to prove that this is 1, 1. So for that, what we will do, we will assume two values from the first set. What is the first set? Non-zero real number. So x1 comma x2 belongs to R0, that's the domain. Such that this we always do, fx1 is equal to fx2, and we get a 1 by x1 is equal to 1 by x2. Now, Abdul, please tell me that what value will never be assumed by x1 because x1 is in denominator, so it will take
0.
0. Okay, but if you will check the set, then the set is non-zero real number. So this is very good. They have already given that you need to select non-zero real number only. So that is fine. That's why 1 by x1 is equal to 1 by x2 is okay. We have done a reciprocal both sides. We get x1 is equal to x2. So you know this. If you will get this one, then we can say that the given function is 1, 1. Okay, Abdul?
Done, sir.
Okay, very good. So please try to prove onto. Okay, you already know the steps. Please apply those steps and try to prove that this is onto. Okay, Ananya, my voice is now audible. Voice is clear to you? Ananya, please reply me on the chat box. My voice is audible. Is it clear? Okay, now we will check for onto. You already know the steps. What we need to do, we will assume a value, let y belongs to R naught. R naught is what? Codomain. Codomain such that fx is equal to y. Fx means 1 by x is equal to y. Okay. Now, what we will do, we will find x in terms of y. So we will get 1 by y. Now, please check here for all y belongs to R naught, 1 by y belongs to R naught domain. Okay, please check here. In place of y, if you will put any non-zero real number, then 1 by y will also be a non-zero real number. Okay, I hope this concept is clear to everyone now. If you're putting any non-zero real number here, then 1 by y will also be a non-zero real number. Thus for all y belongs to R naught, there exists x is equal to 1 by y belongs to R naught, that is the domain, such that fx is equal to 1 by x is equal to y. Hence, the given function hence the given function is onto. Okay, so you need to mention the same steps everywhere. Okay, so please note down this if this is clear to you, and if you have a doubt, then please let me know. Okay, I hope this is completed. Shall we check the second part of this? Fahad, Rifat, and Abdul, shall we check the second part? Today we will complete this chapter. I know you might get bored with this chapter, okay, but we will complete it today. Okay, Rifat, Fahad, and Abdul, this time. Fahad and Abdul. Okay, Fahad. Abdul, this time. Abdul, please raise your hand if this is done. Abdul, this time shall we start next? I guess Abdul, you have also completed this, so I'm going to erase this one. Okay. Now, the second part. Now, what they're saying is the result true if the domain R naught is replaced by N. So, what does this mean? Now, we will have the same function, but the set will change N to R naught. Okay, the function will remain the same. Fx is equal to 1 by x. So, we need to check that this is still 1 1 and on 2 or not. Okay, so what we have right now, we have a natural number here and we have a R naught here. So we need to check that this is 1 1 and on 2 or not. Okay, so for the 1 1, again we will do the same process. We will assume let x1 comma x2 belongs to first set, that is n. Okay, no need to mention domain and codomain because the sets are different, such that fx1 is equal to fx2. So this means what? 1 by x1 is equal to 1 by x2. So this means what? This implies x1 is equal to x2, hence the given function. Hence the given function is 1 1. Okay, is 1 1. So that means there is no effect on this one if we will change the domain. Now, everyone, please note down this. Raise your hands once it is done. Then we will check the onto. Okay. Please raise your hand once you will complete this, or I will ask you to please try onto, and then we will check. Okay, first of all, please raise your hand if you have completed this. Okay, Fahd, very good. Abdur and Fahd, please raise your hand if this is done. Abdur and Fahd, please raise your hand if this is completed. No, other in denominator, in this case also, we will never get a zero. Why? Because we are putting a natural number. Okay, in natural number, we never have a zero. Okay, Abdul?
Okay, sir.
Okay. Okay, so I hope everyone has done this. Fahad, I hope you have completed this. I'm going to erase this one. We will check the next part. Okay. Next one. Next is onto. Okay. Onto function. This is somewhat tricky. Okay. So we have this function. Function is from n to r naught, and fx is 1 by x. So we will assume a value, let y belongs to r naught. No need to write domain and codomain because both the sets are different, such that, but in case if you wish, you can write it over here, codomain, but in this case, there is no need, such that fx is equal to y. What is fx? 1 by x is equal to y. Now take a reciprocal, you will get x is equal to 1 by y. Okay. Now please tell me that this is a onto function or not. I will draw the arrow diagram for you. So what we are doing here, we have a natural number. Here we have a r naught. Okay. So we need to check here that every element which is present in this set, in this r naught, have their pre-images over here. So is there any value? Okay. Think in this way. Give me a value of y so that this complete expression 1 by y will not be a natural number. Give me one value of y here so that 1 by y will not be a natural number. Natural numbers start from 1. 1, 2, 3, 4, 5, 6. Fractions are not natural number. Okay, further has given the example 2. So we will write for y is equal to 2. 1 by 2 does not belongs to the natural number. Okay, that means that means 1 by 2 do not have 1 by 2 do not have its pre-image pre-image sorry, I have written the opposite. Just give me a minute. That means 2 do not have its pre-image, hence the given function, is not is not onto. Okay, so please analyze here. Here you have 1, 2, 3, 4, 5, 6. So what happened when you will put 1? You will get a 1 here. You will put 2, you will get a 1 by 2 here. You will put 3, you will get a 1 by 3 here. You will put 4, you will get a 1 by 4. You will put 5, you will get a 1 by 5. So that means here in the real number, the 2, 3, 4 do not have their pre-images. Okay, because we have a fraction here. So whatever the value of x we will put, this will become an infraction. So we can say the integers. Okay, integers do not have their pre-images. Even we can say negative numbers do not have their pre-images. So it is okay if you will give a simple example. So Abdul, Fahad, and Rifat. This is clear now? Okay, Fahad. Abdul and Rifat, this is clear? Okay, Abdul, very good. Okay, so now you have seen that if even you are changing a set, function is same, but if you are changing a set, then the complete situation will become reversed. Okay, so please note down this. I will give you 1 minute. Please note down this, and then we will start the next question. So total, we still have 6 questions, and we have half an hour for this chapter. Okay, no issue. Okay, Abdul, very good. So Fahad and Rifat, I guess you have also completed this. Now we will start the next question. Okay, next is prove that the greatest integer function given by this is neither 1 1 nor onto where this denote the greatest integer function. Okay, so last year you have already done the greatest integer function, and I know that you do not remember this. Okay, fx is equal to greatest integer function. So first of all, we will discuss that what is greatest integer function. So to remember this, please always learn this statement, greatest integer less than equal to. Okay. Always please learn this statement, greatest integer less than equal to. From this statement, you will always remember that what is exactly a greatest integer function. Okay, so suppose I will put a value here 5.6. What is this statement? Greatest integer less than equal to. So please tell me all the integers which are either equal to this or less than this. Integer which are equal to 5.6 or less than 5.6. So there is no integer which is equal to 5.6. So the integer which are less than 5.6 is 5, 4, 3, 2, 1, and so on. This is clear to everyone? Okay, so whenever you get a greatest integer function, then always write the integer which are either equal to that number or less than. Now from these number, always select the greatest one. So greatest number is 5. So your answer is 5. Okay, so greatest integer function, how can you find out? For example, you have 7.8. Then who can tell me? Abdul. Abdul, please tell me the integer which are less than or equal to this.
So 1 to 6.
Can you say 7, 6, 5, 4, 3, and so on? This correct, Abdul? Abdul, this correct?
So but 7 cannot come, right?
Why we can't take 7? The statement is less than or equal to. So you need to select a number which is either equal to this or less than this. So 7 is less than 7.8. So can we write this? Abdul, this clear? Abdul, if you have a doubt, then please let me know. Okay. Now from this, you need to select the maximum, the greatest one, so that is 7. Okay. So the final answer is 7. Now, Abdul, the last question from you, 9.5. Tell me the integer which are less than or equal to this one.
So till 8.
Abdul, why till 8? Why not 9? You need to find out all the integers which are either less than or equal to this. So 9 is less than 9.5, so we can use here 9, 8, 7, and so on. So we can select the maximum value. We will select the maximum value, that is 9. Abdul, this last question, 14.2. Please tell me the integer which are less than or equal to this. Abdul? Integers which are less than or equal to 14.2. Abdul, you can tell me if you have any doubt in this one. Abdul, if you have any doubt, then please let me know. Okay, it's not an issue. Maybe there's some confusion in this. Please tell. Okay, Fahad, can you tell me the integer which are less than or equal to 14.2?
14 to 1.
14 to 1. Are you saying this?
Yeah.
Okay, very good. Okay, and so on. And the greatest of these is
14.
14. So the answer is 14. You can directly tell me the answer if this is clear to you. So what I'm trying to say is whenever you will get a number and you need to find its value, it's the greatest integer function, then always write all the numbers which are either equal to or less than that. Okay. And from those numbers, please find the greatest one. Okay. So Rifat, this question is for you. Suppose we have 17.5. So Rifat, can you tell me the final answer directly? 17. Very good. So Abdur, this last question from you. Suppose we have 20.5. Can you tell me directly the final answer, Abdur?
Sir, 20.
20. Very good. Very good. So I hope this is now clear to everyone. So you understood that what is the greatest integer function. Okay. Now, they are saying the proof that this is neither 1, 1 nor onto. So what we will do, we will just give a simple example. There's no need to complete proof this, just give an example. Is neither 1, 1 nor onto. So you need to give two values which have the same image. So Fahad, please tell me two numbers which have the same image. Means I will put one value in the greatest integer, I will get the same answer. I will put next value, I will get the same answer. Fahad, can you tell me two values? Okay, not issue. Tell me first what's the value of this 3.4. Very good for 3. First, tell me the value of this 3.7. Very good, 3. So you can see here 3.4, 3.7 have the same image 3. Okay, so you can write here 3.4 and 3.7. Okay, even you can write like this, f 3.4 is equal to this one, f 3.7 is equal to this one. So 3.4 and 3.7 have the same image, hence the given function is not 1, 1. Okay, so I hope this is clear to everyone. If anyone have a doubt, then please let me know. Okay, if you don't have a doubt, then please note down this and check for onto. For onto, I will draw the arrow diagram. You can get the hint from here. Okay, so please tell me the values which are present in second set which do not have their pre-images. Please try to find out the values in the second set which do not have their pre-images. Okay, so I think everyone has noted down the first part. Okay, we'll check for the second one. Second is onto. Now, if okay, we will take some. Shall I rub this part one by? Shall I rub this part? Abdur, Fahad, Rifat. First one is done. Okay. Now, please check here for the second one onto function. Please try to analyze the result. 10.6. Abdur, what is the answer? Abdur, for 10.6, what's the answer? Abdur,
Yes, sir.
for 10.6, what is the answer?
Sir, 10.
Very good. Fahad, for 9.8, what is the answer?
9.
Very good. Rifat, for 6.9, what is the answer? 6. Very good. So if you will analyze this, then please check here. First set is a real number, so you can put any real number in the function. If you will check the second set is also the real number. But whatever the value you will put in this greatest integer function, the final result is always an integer. Please check here. If you will put any value, any negative, positive, decimal value, any value, the final result will always be an integer. Am I correct? So that means you will put any value here, but the result will always be a integer. Z, this is it. Put any value, but here you will get an integer only. That can be 1, 2, 3. But this set is a real number. So real number will have decimal numbers also. Okay, decimal numbers, negative numbers, all the numbers will be present here. But the result you will get is always a integer. So that means non-integral values do not have their pre-images. So for example, if here we have a 1.4, then this 1.4 do not have its pre-image here. There is no number you will put over here so that you will get a 1.5. In case of greatest integer function, whatever the value you will put, this will give you an integer only. Okay, so I hope everyone understood this, that for the non-integral values, the numbers which are not integers, for example, the decimal numbers, they do not have their pre-images. So we can write it like this. So we can write like this: non-integral values, non-integral values, integral values do not have, do not have, do not have their pre-image, do not have their pre-image. Hence the given function, hence the given function is not is not one. Now please raise your hand if this is clear. Fahad, Rifat, and Abdul, please raise your hand if this is clear, or let me know if you have any doubt. Okay, Rifat. Fahad and Abdul, this clear? Okay, Fahad. Abdul, this clear? Abdul, this clear? Abdul, yes or no? So if there will, then it was on. So if there was pre-image, yes, if there is a pre-image, then this will be onto. But the non-integral values, the number which are in decimal, okay, they do not have their pre-images. That's why this is not onto. So you can check here. You can directly write like this even, that 1.6 do not have its pre-image. Okay, do not have its pre-image. So this is not onto. Okay, Ananya, I have just checked that you had raised your hand. I guess you have some network problem. Now my voice is audible, Ananya?
Yes,
Uh,
sir.
okay, good. So Ananya, this is your first class? Ananya, this is your first class? You can even reply me on the chat box, Ananya, okay? Okay, again, back to you, Abdul. Abdul, now this is clear, the onto function. Abdul. Abdul, please reply me on the chat box, okay, if this is clear to you, or if you have any doubt. I guess you have some network issue. Okay, Ananya, so you had attended few. Okay, not an issue. So Ananya, we are right now, we have completed matrices, determinants, relation and functions we are doing right now. So hopefully today we will complete this relation function. And today only we will start a new chapter, that is the differentiation. Okay, so please wait for a few minutes. We will complete this and then we will start a new chapter. Okay. Okay, so I hope everyone understood this one. Now we're going to start next one. Okay, so what is this? Show that this function is neither one nor onto. Again, we need some examples. Okay, so who will give me the first example? This question is from your NCRT. You need to prove that this is neither one nor onto. So first, okay, but before this, modulus function, everyone is aware about this. You have done this in class 11, but Fahad, Rifat, and Abdur, are you aware about this greatest integer function? Or I need to again explain this? Yes, yes, Fahad, that is correct. Rifat and Abdur, the greatest integer function is clear? Rifat and Abdur, okay. So this modulus function, what is the property of the modulus function? If you will put any value, for example, if you will put -1, then this will give you positive. If you will put 1, this will give you 1. So if you are putting either negative number or a positive number, the answer will always be a positive. Use the method in greatest integer function in onto. No, Abdur, please don't do that. Okay, because it will not possible for you to find x then in terms of y. This is the main issue. If you will take y, then you will write like this: greatest integer function is equal to y. After this, you can't find x in terms of y. So please don't do this in this way. Okay, just write a simple statement that non-integral values do not have the pre-image, hence the given function is not onto. Okay, Abdul? Okay, what non-integral? Those are not integer. What are integer, Abdul? Integer are, for example, this -3, -2, -1, 0, 1, 2, 3, and so on. So these are integers. What are non-integers? For example, decimal numbers, 1.1, 2.4, 3.5. So the decimal numbers, these are not integers. So non-integral means not integers. So that means decimal number. So even in place of non-integral, you can also write the decimal numbers. The decimal numbers do not have the pre-images. Okay, Abdul, this clear?
Okay, sir.
Okay, very good. Now, next one. Next question, we have started the the modulus function. So you know how this modulus function behave. If you will put any negative or positive value in the modulus function, the answer will always be a positive number. Okay. Now, so I need example. First example I have already given here. So who can tell me next? Rifat. Rifat, please tell me two numbers which have the same image. Rifat, please tell me two numbers which have the same image. Your voice is not audible, Rifat. You can message me on the chat box. No, Rifat, why you are taking decimal? This is a modulus, okay? If you will put a -2, Rifat, then what is your answer? This is not a greatest integer, okay? This is a modulus. Rifat, what is the answer if you will put -2? You know that modulus will convert every value into a positive one. So Rifat, what is the answer for -2? Very good, 2. So Rifat, please tell me if I will put 2, then what will be the answer? 2. So we can say -2 and 2. -2 and 2 have the same image. Have the same image. Hence the given function. Hence the given function. Hence the given function is not 1 1. It's not 1 1. Okay. So first Rifat and Abdul, please raise your hand if this is clear to you. Okay, Fahd. Okay, Rifat. Abdul, this clear? Okay, Ananya, this is you have a basic idea about the functions? Ananya, you have the basic knowledge about the functions? Okay, okay, then very good, very good. Abdul, okay, so Abdul, this is clear, the first part. Abdul, the first part is clear. And one more thing, next week you have a subjective test of relation and function. Okay, today we will complete this, and the next week you have the test. Okay, so Abdur, I guess you have some network problem. Now we will start with onto, and you will tell me the answer. Okay, all of you, please tell me on the chat box. So I will give you the hint. This is first set, that is a real number. This is second set, this is also a real number. Okay, we need to prove that this is not onto. So please tell me which numbers are there in the second set here. Which numbers are there which do not have its pre-image? First, what is R3? Yes, yes, in real number, decimal numbers come. Okay, but in integer, the decimal numbers do not come. So, but modulus do not have any effect of the decimal number. Even if you are putting -2.3, then you will get a 2.3. Okay. Okay, so please tell me in the second set, which are the numbers which do not have their pre-images in setting? Just analyze this. You're putting negative number or positive number, the answer is always positive. So please tell me what are the numbers in the second set which do not have their pre-images? Yes, Ananya, what's the answer? Ananya, what is the answer? You have raised your hand. Anyone? Fahad, Rifat, Abdul. Which elements in the second set do not have their pre-images? Who can tell me? Abdul, Fahad, Rifat. Which elements in the second set do not have their pre-images? Please analyze in this way. If you are putting any value, negative or positive. Yes, Abdul, are you saying something?
It's a -2 and 2.
Yes, so that means, yes, you can say that -2 do not have its pre-image. Okay. Or if you will, no, first 1 by 2 is there. If you will put a, suppose 1 by 2, then here, I'm writing here. If you are putting a 1 by 2, then answer will be 1 by 2. So that means 1 by 2 have its pre-image. In case of modulus, what is happening if you're putting any number? If you're putting any number, the result is always positive. So that means the negative number here, in the second set, the negative numbers do not have its pre-image. For example, if you will put -2, then answer will be 2. Then what will happen about -2? In the second set, -2 is also present, but it will not be associated. Yes, yes. Now you are correct for. Okay, so that means negative numbers do not have their pre-images. So you can write like this. Either you can give an example as Abdur has given -2, Fahad has given -2 by 3. So you can say that -2 do not have its pre-image, -2 by 3 do not have its pre-image, or you can say negative numbers, negative real numbers, negative real numbers in codomain. Okay, codomain means we are talking about the second set. Negative real numbers in codomain do not have their pre-image, do not have their pre-images. Hence the given function, hence the given function, hence the given function is not onto. Okay. Negative numbers in codomain do not have their pre-images, hence the given function is not onto. Or you can give an example, -2, -4, -6 do not have their pre-images, hence it is not onto. That is also correct. Okay. So I hope this is clear to everyone. Ananya, I guess you might have some network issue. This is clear, Ananya? Ananya, this is clear to you? Okay, Umair, you were not present yesterday and today also you have joined 50 minutes late. Umair, what's the issue? Umair, in every class you normally join after 30 minutes. You have exam, Abdur. Okay, Abdur, you can leave, but today we will start the differentiation. But today we will discuss the differentiation of 11th only, not of 12th. Okay, so please check the recorded lectures. Okay, Abdur? We will
Okay, sir.
revise the 11th differentiation today. Okay, very good. Okay, Abdur. So, okay, Umair, in every class you join after 30 minutes. What's the issue? From the next class, Umair, please be on time. Okay. So, Umair, first one, the function is modulus function. Okay, you know that if you will put any value in the modulus function, it will give you the positive answer. So if you need to show that this is not 1, 1, then we have put a -2, we get a 2. We have put 2, we get a 2. So that means -2 and 2 have the same image. Okay, -2 and 2 have the same image. Hence, the given function is not 1, 1. Because two elements have the same image, so this is not 1, 1. Now we are discussing about the onto function. So, Umir, if you will analyze the second function, then second is a real set. So this real set have a negative and positive values also, but the negative values do not have their pre-images because you are putting any value, the final result is always positive. So that means in the second set, the negative values do not have their pre-images, hence the given function is not onto. Clear, Umair? So I will give you 1 minute for this. Please note down this, then we will start the next question. Okay, Umair, second one. If you will put any value here, Umair, if you are putting -3, you are putting -4, the final result is always positive. Okay, so that means in the second set, the negative numbers do not have their pre-images. Okay, the negative numbers which are present in set B do not have their pre-images. Hence, we will say that the given function is not onto. Okay, Umair. So please note down this. I will give you 1 minute, then we will start the next question. Only 4 questions are remaining. Okay, then our chapter will be done. So Umair, I'm going to start next one. This done, Umair? Fahad, shall we extend it for 1 hour? Is it okay, Fahad? Okay, okay. I will give you a 5 minute break once we complete this chapter. Okay. Okay, and one more thing, we will make a group on WhatsApp. So you need to share the assignments on WhatsApp only. So that will be convenient for you. Okay, and but please share the PDF copy. So you can take the screenshot by the cam scanner and you can convert that into PDF. So that will be very comfortable for me to check your assignments. Okay, some of the times the screenshots are not very clear. So you can take the screenshot by the cam scanner. In last test, some of the students had shared their answer sheet in PDF. Okay, so you can also do in the same way. Umair, I guess this is done. Now we can start the next question. This is a very, very simple question. So this is your homework. Okay, we have done many questions of this type. This is a simple question. For example, 2x plus 3. So this question came in CBSE 2010. Please note that this question and do this in homework. Okay, I will give you just 1 minute for this. Please note down this. Then we will start the next question. Very simple question. Just apply the same methods which we have applied in some of the previous questions. Okay, please raise your hand if this is done. Okay, Fahad, very good. Rifat, Umair, and Ananya, please raise your hand so that we can start the. Okay, Rifat, good. Ananya and Umair, this done. I hope everyone has done this. Okay, so I'm going to start next question. Okay, this is also a very good question. First, we will check for 1, 1. Okay, so I hope everyone know about the trigonometric functions. You know the graph of trigonometric functions. Cosec graph is like this. This is 0. This is pi by 2. This pi. This is 3 pi by 2. And this is 2 pi. Okay. Now, fx is equal to cos x is given. We need to prove that this is not 1, 1. So we will just give an example. So fx is equal to cos x. Now, who can tell me the value of f0? Where's the value of f0?
1.
Very good. Cos 0 is 1. Tell me the value of f 2 pi. What is cos 2 pi? 2 pi means 360. What is cos 360?
-1.
No, this is 1. Okay. So check here. At 0, we have the value 1. At 2 pi, we have the value 1. So 0 and 2 pi have the same value 1. So we can write 0 and 2 pi have the same image. Have the same image. Hence the given function. Hence the given function. Hence the given function is 1. Sorry, is not 1. Okay. Now for onto. Who can tell me? In this case, we have two sets. First set is R, real number. Second set is also R. Okay. Now, please tell me, Furth, what is the minimum value of this cos? What the minimum value this cos function will attain?
Sir, pi.
Minus 1.
Minus pi.
Minus 1, sorry. Minus 1. Okay. From the graph, we can check. If you will put any angle, the minimum value you will get is minus 1. Okay, please tell me what is the maximum value this cos function will take? No, Furth. Umaid, anyone else? What's the
So
maximum?
1.
Okay, you can check from the graph. The maximum value will be 1. So cos function will take just. Okay, so the cosine function will take the maximum value 1 and minimum value minus 1. Okay, so you will get all the values from -1 to 1 here, from -1 to 1. Now, this is a function from R to R. Here you can put any angle, it's fine. In the real number, you will just get the value from -1 to 1. All the numbers from -1 to 1. Okay, -1 is pi. If you will take the value pi from here, from the graph only, you can check on it. If you will take the angle pi, then you will get a -1. Okay. Okay, Omer?
Okay, sir.
Okay. So if you will check the second set, then say second set have the real numbers. Okay. But what image every time you will get, that is from -1 to 1. So that means the values other than the numbers from -1 to 1 do not have their pre-images. So we can write like this: a real number except we can write like this: -1 to 1. Okay, so we have written like this: real number except -1 to 1. That means from the real number we sorry. Okay. Just so from the real number, if you will subtract this -1 to 1, then you will get the remaining result, remaining number. So we can write real number except -1 to 1 do not have their pre-images, hence the given function is not onto. So this is clear to how many students? Please raise your hand if this is clear.
So can you explain again?
Yeah. So for what we have said over here, that whatever the angle you will put in this set, then your image will lie between -1 to 1 only. You can put any value here, but the answer you will get, that is from -1 to 1. That means the rest of the
Except
numbers.
-101, we should not put any value, right?
No, I'm not saying this. I'm saying that if you will put any value in the first set, the answer will
Suppose
lie
of
-1 to 1. whatever, for example, if you will put a 0, then what you will get? 1. If you will put pi by 3, so that means cos 60 degree. What is cos 60? 0.5. Okay, if you will put f pi cos 180, you will get a -1. So I'm saying whatever the angle you will put in the cosine, then result will lie from -1 to 1 only. Okay, so that means in the second set, only the numbers between -1 to 1 have their pre-images inserted. The rest of the number do not have their pre-images because there is no angle which will give, for example, we will take a -10. So is there any angle for Earth which you will put and you will get a -10? Is it possible? For example, in the second set, you have a real number, for example, -1000. Is there any angle which will give you a value -1000? No. You will always get the result from -1 to 1 only. Okay. So the same thing I have written over here, that real number except -1 to 1 do not have the pre-images. From the second set, except the number -1 to 1. Except the number -1 to 1, rest of the real number do not have the pre-images. That's why this function is not on. Only 1 and -1 in that range only have pre-image. No, I'm saying in that range. Yeah. Umair, if you're saying the value from -1 to 1, then it's fine. Okay. If you're saying the value from -1 to 1, that all the numbers from -1 to 1, then it's fine. I'm not saying that only 1 and -1 have their pre-images. I'm saying all the numbers from -1 to 1 have their pre-images. Okay. So now is it clear? Fahad, Umair, Rifa, what would be the criteria for it to be onto? First of all, tell me, Umair, what is onto function? We have already discussed.
Sir, the onto function is a function in which all the images have their pre-image.
All the elements in set B have their pre-images. Okay. So if there is any element in set B which do not have the pre-image, then we will say that this is not onto. So please check in the second set. Second set is real number. Is there any element which do not have its pre-image? Umair?
No, sir.
Yes, they are infinite values. They are infinite values which do not have their pre-image. So whatever the angle you will put, the answer you will get only this one, -1 to 1. The rest of the elements do not have their pre-image. You will never get a -10. Is there any angle, Umair, which will give you -10?
No, sir.
No. So that means,
So in
yes,
set B, we are considering all the real numbers, right?
yes, because it is given in the question. Please check here. The real number is given. So in
Oh,
this,
okay.
okay. So in the set B, we are considering the complete real number, but costs do not give you the image except -1 to 1. That's where rest of the real number do not have the pre-images. Okay. Okay. So Fahad, Rifat, and Ananya, and Umair. I hope now is okay. Fahad. Okay, Ananya. Rifat, this is clear. Okay, very good. Umair, I guess this is now clear to you also.
Yes, sir.
Please. Okay, very good. So all of you, I will give you 1 minute. Please note down this. Then I guess only 3 questions are left. We will complete that right now. Okay, so I hope everyone has done this. Now we are going to start next part.
Sir, can you show the previous slide?
Okay. Okay, just give me a minute. I need to check it. 3 questions. Please note down this.
Sir, can you give me 2 minutes to write it?
Yes, sure, Umar. For if in place of x, if you will put any angle, then you will get the value between from -1 to 1. Okay, not -1 or 1, from -1 to 1. Okay, so if this is a real number line, then this is -1, 1, all the numbers from -1 to 1. That means all decimal number, all this. Okay. Umir, is it done? Shall we start next?
Oh, yes, sir.
Okay, okay, very good. Now, next one, this. Let A is equal to this and B is this if f is a function from A to B is a mapping. Okay, it's a function defined by this, show that f is bijective. Again, same 1, 1. Okay, so please check the steps. You already know that we in 1, 1 we assume two values belongs to set A such that fx1 is equal to fx2. This means x1 minus 1 by x2 minus 2 is equal to x1 minus 1 by x2 minus 2. Okay, just cross multiply these two. So x1 minus 1 into x2 minus 2 is equal to x1 minus 1 into x2 minus 2. Open this bracket. X1 x2 minus 2x1 minus x2 plus 2 is equal to, open this bracket, x1 x2 minus 2x1 minus x2 plus 2. So cancel out this 2, minus x2 cancel out this, x1 x2 cancel out this one. So finally what you will get here minus 2x1 is why we are getting here minus 2x1. Sorry. We will do this again. So fx1 means x1 minus 1 by x1 minus 2. Fx2 means x2 minus 1 by x2 minus 2. Now cross multiply this, so you will get x1 minus 1 into x2 minus 2 is equal to x2 minus 1 into x1 minus 2. Okay, first we have just started this question. Okay, so we need to prove that it is bijective. First of all, we will check for 1, 1. So we have assumed two values from the set A. We have just mentioned fx1 is equal to fx2. Fx1, you know this, in place of x. Ananya, I will leave the class in 15 minutes, okay? Because Fahad and Rifat are doing the class from the last almost 1.45 hour. Okay, so we will complete this chapter today. Differentiation we will start in the next class. Okay, and this week you have the test of relational functions. Okay, now please open this bracket. This is x1 x2 minus 2x1 minus x2 plus 2. Open this bracket, x1 x2 minus 2x2 and minus x1 plus 2. Cancel out this, cancel out 2, and okay. Now this is minus 2x1. Shift this x1 to the left side, so you will get minus 2x1 plus x1 is equal to minus 2x2 plus x2. Here you will get a minus x1 and here you will get a minus x2. Cancel out the negative sign, you will get x1 is equal to x2. Okay, so I hope this is clear to everyone. So we will say hence the given function is 1 is 1 1. Okay, So please note down this, raise your hand if this is clear and you complete it, then we will check on. Yes, Fahad, we have just done the cross multiplication. Okay. Okay, Fahad. So what we have done first, we have just multiplied this one. So we have opened the bracket x1 into x2, then x1 into minus 2x1. Okay, or it is better if you will do the calculation on your own. Mhm. So x1 into x2, then x1 into minus 2, minus 2x1, then minus 1 into x2, minus x2, minus 1, minus 2, plus 2. Similarly here, x2 into x1, x1, x2, minus this, then we have cancelled out 2, we have cancelled out x1, x2, we have shift the x1 to left side and x2 on the right side. We get this. So for it will be better if you will do the calculation on your own. Okay. First, please do the calculation on your own and let me know if it is clear to you. Okay, is it done? Shall we start the next part on to? Please raise your hand if this is done. Just wait for 10 more minutes, okay? We will over the class in 10 minutes. Okay, Ananya, good. Fahad, Omer, and Rifat, please confirm if this is done. Shall we start next? Fahad, Omer, and Rifat. No reply means it is done. So I'm going to start next one. Okay, shall I raise this one? Shall I raise this? Okay, then I'm going to start next onto function. Okay, for onto, what we will do, we will assume a value, let y belongs to B, such that fx is equal to y. Okay. I know that this chapter is quite difficult. That's why most of the questions we have completed in class only. Okay. Next is x minus 1 by x minus 2. This is equal to y. Now we need to find x in terms of y. So what we will do, cross multiply y into x minus 2. X minus 1 is equal to, open the bracket, xy minus 2y. X minus xy is equal to minus 2y plus 1. So take common x, you will get a 1 minus y. This is equal to minus 2y plus 1. X is equal to minus 2y plus 1 by 1 minus y. Okay. Now please check here, if you will put any value of y from the set B, then what the result you will get, please check here. What is set B? Real number except 1. So if you will put any real number x, because if you will put 1, then you will get, then in the denominator this will be 0. That will be not defined. So we will never put a 1 over here. And even in set B also they have given real number except 1. So if you will put any real number except 1 in place of y, then this complete expression will always give you the real number. Okay, you can check this expression. If you will put any real number except 1, then the complete one will always give you the real number. So what we can write here, for all y belongs to B, this expression minus 2y plus 1 by 1 minus 1 will belongs to A. Thus, for all y belongs to B, minus 2y plus 1 by 1 minus y, no. Just,
Instead of xy, y 1 minus y came.
sorry, sir. Will you please repeat?
Instead of xy, y 1 minus y came. Fifth
Sorry,
line. Fifth line.
fifth line, 1, 2, 3, 4, 5. This one?
Yeah, yes, sir.
So everything is fine. We have taken x common here.
You-
Okay, from this we have taken x common. So we get a 1 minus y. Then we have shifted this 1 minus y in the denominator. Okay,
Yes, I
for?
got. Yes.
Yeah, so we are saying this, for all y belongs to B, there exist x is equal to minus 2y plus 1 by 1 minus y belongs to set A, such that the same language which we always write, such that fx is equal to y. Sorry, fx is equal to x minus 1 by x minus 2 is equal to y. Hence the given function is onto. Okay. So please note down this, raise your hand. Once it is done, then only 2 questions are left. We will complete those 2 questions. For in place of y, we will put the numbers from the second set. Second set means this one, r minus 1. So if you will put in this expression any number from the set B, then this complete expression will always give you the number, this one from the set A. That means even you will never get 2 in this expression. Okay, if you wish, you can check in the bracket. So I'm saying that this expression will always give you the number from the set A. Even you can check this, that this expression will never give you 2. Why? If you will put 2y plus 1 by 1 minus y is equal to 2. Open this bracket, minus 2y plus 1 is equal to 2 minus 2y. Shift this 2y on the left side. We can cancel out this. Finally, you are getting a 1 is equal to 2. But we know that 1 is not equal to 2. Why we are getting this error? Because your expression is not equal to 2. This is not correct. So even hence minus 2y plus 1 by 1 minus y is not equal to 2. Okay, Fahad? So whatever the value of y you will put, the x will always belongs to R except 2. Even you will not get 2 here. We have proof in the bracket. So everyone please raise your hands. Once it is done, then we will start the next question. Everyone, this is done. Shall we start next? Please raise your hand if this is done. Okay, now we have only 2 questions are left.
Sir, can you show the previous answer?
Yes, yes. Please note down this. Confirm. Umair, is it done? Shall we start next? How to write the statement? Okay, so Umair, please remember, we always write this statement. Once you will get this expression, then we will always write that we will first of all analyze this expression, that if you are putting the value of y from the second set, will all the elements will belong to the first set or not? If yes, then we will always write like this: for all y belongs to B, this complete expression belongs to A. Yes, Fahad. In every step, we need to perform the same steps. Okay. So relation function is, yes, difficult, but steps are same. Okay. So for we will always write that for all y belongs to B, there exists x is equal to belongs to A, such that fx is equal to this one is equal to y, hence the given function is onto. Okay. Now we will start the next one. Next is we need to prove that this is bijection, so we will start from 1 1. Umair, yesterday we have done this thing in detail. Okay, what is standard statement we need to write? So you can check the yesterday's lecture also. Okay, now 1 1. Let A and B be two sets. Show that f A cross B to B cross A defined by f A B is equal to B A is a bijection. So now, in place of a set, they have given the Cartesian product. That's why this time we need to assume every value as an ordered pair. Okay, so from this time we need to assume a value as an ordered pair. So first of all, we will write Lect we will assume a value from the first one. So this is what this is ordered pair. So we will assume two values, let A1 comma B1, A2 comma B2 belongs to A cross B, such that F A1 B1 is equal to no, for after this there is one more question. Okay, such that FA1 B1 is equal to FA2 B2. This implies what is A1 B1, what is FA1 B1? B comma A. So we will get here B1 comma A1 is equal to what is A2 B2? B2 comma A2. So from here what we can say B1 is equal to B2 and A1 is equal to A2. So what we can say that ordered pair A1 B1 is equal to ordered pair A2 B2. Hence the given function Hence the given function is 1 1. Okay, so in 1 1 we need to show that A1 B1 is equal to A2 B2. Why we have assumed the ordered pair? Because the Cartesian product is given as a set. So please note down this, confirm me, then we will start with onto. Okay, please note down this and raise your hand. Okay, so Umair, what is the question here? Question is, first of all, two ordered pairs are given. A cross B is equal to B cross A. After this, they have given this one, FAB. So that means in the function, if you will put a ordered pair AB, then the result will be BA. So that means if you are putting 1 comma 2 here, then the final answer will be 2 comma 1. Okay. So in 1 1, what we always do, we assume two values from the first set. So A1 B1, A2 B2, we have assumed from the first set, that is A cross B, such that we always write like this: F first value is equal to F second value. Now, if we will put this one A1 B1 in the function, then what we will get? This one. First B, then A. So B1 A1. Similarly here, we will get a B2 and A2. Now B1 will be equal to B2, A1 will be equal to A1. So what we can say, this ordered pair, these two are equal. Why? Because A1 is equal to A2 and B1 is equal to B2. Hence these two are equal. Hence the given function is 1. Okay. So is this clear? Ananya, Fahad, Umair and Ifad. This clear?
So can you explain that B1 A1 is equals to B2 A2?
Which
The third line.
third line? This one. Okay. Okay. So for please check here. Function is what? If you will put AB, you will get BA. So here, if we are putting A1 B1, then what will be the result?
Okay, okay. B2 and A.
B1 A1. Okay. Here
B1.
also, if we will put A2 B2, what will be the result? B2 A2. Okay. Is it okay for now?
Yes, sir.
Okay, very good. Okay, so finally we get this. Now all of you, please note down this and confirm me. Then we will start the bijection. Sorry, onto is quite tricky. Okay, I hope everyone has done this. Shall we move to next? I'm going to erase this one. Please let me know if anyone is still doing this. I'm going to erase this. Okay. Second is onto. For onto, what we will do, we will assume a value from the second set, that is B cross A. We will assume let B comma A belongs to B cross A. Why we have taken B comma A? Because the ordered pair is B cross A. let B comma A belongs to this. Okay, so this implies if this ordered pair belongs to B cross A, then this means B belongs to B and A belongs to A. You know how to find the ordered pair. So you know this element will always belong to this set, A belongs to this. Okay, so this implies if B belongs to B and A belongs to A, then we can say A comma B belongs to A cross B. Okay, so what we can say here this for all B comma A belongs to B cross A, there exist A comma B, there exists A comma B belongs to A cross B such that F A comma B is equal to B comma A. Hence the given function. Hence the given function is onto. Okay, so what we are saying that B cross okay. Okay, Umir, please check here. So for onto, we always assume a value from the second set. Second here is B cross A. And we always show that for this value, there exists a value in set A here. So if this value belongs to B cross A, then this means small b will belong to the set B, small a will belongs to the set A. So hence we can say that A comma B will belongs to A cross B, because B is there in B, A is there in A, so A comma B will belongs to A cross B. That's why we are saying this for all B comma A belongs to B cross A, there exists A comma B belongs to A cross B, such that FAB is equal to B comma A. Hence the given function is on 2. Now a last question is remaining. So shall we complete that question today or in the next class? I know
So today you can do.
today Fahad, Rifat, next class. Actually, Umir, Fahad and Rifat, they're doing the class from more than 2 hours. Okay, they always join 30 minutes earlier. Okay, so I do understand that now they're tired. So only one question is remaining. I need 10 minutes for that question. So it's fine. We will do that question in the next class and start the differentiation. Okay. So, okay. And next thing, please remember, in this chapter, most of the questions I have completed in the class. I have not given so much of homework. Even the homework which I have given, most of the students have not completed that. That's fine because of the important question we have done in the class only. Now the rest of the chapters are quite simple. They are not tough. So I will give you a lot of homework. So please do that. Okay. And this week you have a test of relation functions. Please be prepared for that. We will take a subjective test. Okay. Okay, then. Thank you so much. Okay. Okay, so we will over our class. So we will continue next week. Thank you. Okay, Ananya, Umair, and Rifat, we will continue our class next week. Okay, so I'm going to end the class. Umair, can you check the recorded lectures? Okay, because yesterday we have done many questions in detail. Okay. Okay, I will. So Ananya and Rifat, if you wish, you can drop. Okay. So Ananya and Rifat, I'm just explaining Umair about the bijective function. So if you wish, you can drop. And but Umair, what I expect from you that from the next class, please be on time and do not miss the classes. Okay, so please check here, Umir. For 1, 1, always remember the steps. For 1, 1, what we do, we assume the value. Let, for example, we have this function, fx is equal to x cube plus 2. So this is a function R2R. What we do, let x1 comma x2 belongs to the first set, R. You are welcome, Ananya. Okay, we will continue in the next class. Okay. So what is this R? This is the domain. So please write if both the sets are same. Domain. Such that fx1 is equal to fx2. So fx1 means x1 cube plus 2 is equal to x2 cube plus 2. 2 cancel out. X1 cube is equal to x2 cube, and take the cube root on both sides, so you will get x1 is equal to x2. Hence